Okay, so you guys are all here for factoring using the AC method, which I usually just call factoring by grouping because you use the grouping process when you do this. So there are 4 steps essentially to this. And I'm starting with factoring by grouping because you need to understand what factoring by grouping is before you can factor using the AC method. So factoring by grouping, you have to have 4 terms. And so first, you always factor the greatest common factor out. That's always the first thing you do, no matter what it looks like. So always do that first. And then you're grouping pairs. So you're grouping the first 2 terms together and the last 2 terms together. And by extension, grouping can also work if you have 6 terms. It can work anytime you have an even number of terms. We usually only do it with 4, though. So once you've paired things together, then you factor the greatest common factor out of each pair. So instead of factoring all 4 together, you factor out pairs, which is a lot easier. It's easier to find things in common between 2 things than to find things in common between 3 or 4 things. Once you do that, then you factor out the binomial factor. You're going to end up with something in parentheses that's identical, and you factor that out. That is basically reversing the distributive property, which I showed in the factoring video with the greatest common factor. So that is the reverse distributive property. So here's the first example that I have with grouping. So we have 4 terms here: 4x cubed plus 3x squared y plus 4xy squared plus 3y cubed. So looking at this, all the coefficients are either 4 or 3, and they don't have anything in common. And then only 3 of the terms have x's, and only 3 of the terms have y's instead of 4 of them, so we can't even factor out any letters. So there's no greatest common factor here. We have to go straight to the grouping process. And so you pair things together. So I'm going to put the first 2 in parentheses. When you do this, you need to keep a plus sign in between the pairs, because if you don't, then it starts looking like multiplication. So you need to make sure you remember that there is a plus sign between each pairing, because these are all added together. So now the first pairing is 4x cubed plus 3x squared y. So we need to identify a greatest common factor there. So between 4 and 3, there isn't any number, but they both have x. One has an x cubed, one has an x squared. So the greatest common factor will be x squared, since that is the smallest exponent. The next pairing, we have 4xy squared and 3y cubed. So again, 4 and 3 don't have any numbers in common, but these 2 terms both have y's. So the greatest common factor in this pairing would be a y squared, since that's the smallest exponent. And so now we're going to factor these out from each pair. So I'm going to show all of these steps, and I'm going to show the method where I divide, because that's my preferred method. That was method 2 that I talked about in the greatest common factor video. So we are dividing our greatest common factor out of each pairing. So I'm just writing every term divided by the greatest common factor that associates with it. So I've got x squared, so that's taken out of the first 2. And then the y squared is only taken out of the last 2. So now I'm going to simplify. So I keep my x squared in front for the first set. And then I follow the rules of exponents where I subtract the exponent. So that's going to leave me with a 4x plus 3. The x squareds cancel, and I'm left with just a y. Then I have y squared, and I'm left with 4x, the y squareds cancel, and then 3y. Now notice that in the sets of parentheses, these two sets of parentheses are identical. When that happens, that means you have done this correctly, because if they're not identical, then you can't go further. So they have to match, because that is what we're pulling out. That is the binomial factor that we are reversing the distributive property out. So that goes in front. I don't know why my 4 does not want to get written. It keeps disappearing. It's probably going to show up like 5 times now that I've tried to write it. Oh, I got a line. I don't know what is going on with my stylus there. Okay, finally, I got my 4 to show up. I don't know why it keeps erasing that. So I've got the 4xy, and then your second set of parentheses is what's in front, the x squared plus y squared. And so you end up with 2 binomial factors. The one in front is the thing that matches in parentheses, and then the one in the back is what was in front each of them. That comes from the greatest common factors. So are there any questions? Okay. So example 2, this is another one with 4 terms, so we have to do this by grouping. This one, we have a greatest common factor that we can take out first. So I'm going to first look at the greatest common factor out of 4 of these terms. So out of my coefficients, I have 15 and 10. And the largest number I can divide out of both of those is 5. That's something that I can do relatively easily mentally. So 5 I can divide out of both. Now I look at my variables. I have x's in all 4 terms, so I look for the smallest exponent, which is in the last term, which is just an x. And then I have y's in 3 of the terms, but I don't have it in the first term. So because it's not in the first term, I can't factor out a y. So my greatest common factor is just 5x. So I am going to divide that out of all 4 terms before I do anything else. This takes a while just to write all of this down. Okay, so I have 5x in front, and then I start dividing. 15 divided by 5 is 3. And when I subtract my exponents on the x's, I get x cubed. And then I get plus 3x, and then I have the y squared still. 10 divided by 5 is 2. I get x squared y, and then 2y cubed. Okay, so now I need to start the grouping process. So I'm going to do this in a different color. So now I am going to group or pair things up. And I do this inside of my outside sets of parentheses. So we're going to go through this process, and that 5x is just going to keep hanging out to the left, and we're just going to keep dropping it down. So now I'm going to look at my pairs. So my greatest common factor out of my first pair, the 3x cubed plus 3xy squared. So that's going to be a 3, and then they both have x's. It's going to be a 3x. My second pair, I can have a 2 and a y. So I'm going to try to color code all of this. So I've got my 5x parenthesis. And now I'm going to factor out my 3x. So I'm taking the 3x that I'm dividing from each term. And then I'm taking out a 2y that I'm dividing from each term. So this does start looking really messy because we end up with parentheses inside parentheses. If it makes it easier, you can turn maybe the outside sets of parentheses to brackets if you want. So if that makes it easier for you visually, you can make those brackets, or you can make the inside ones brackets, whichever is easier for you. So I guess since I made them brackets, oh, it's disappearing again on the, for some reason my stylus does not want to write in this bottom left corner. There we go. So now I'm going to do my division. So the 3's cancel. X squared over x becomes an x squared. And then I get a y squared. Then plus 2y. The 2's cancel, the y's cancel. I'm left with x squared plus 2's again. You subtract your exponent, so you get a y squared. So inside my parentheses, I match. That's going to be what I'm going to factor out. So how this works is my 5x is in front. And now I can ignore all the brackets. And I'm going to take the first set, which is going to be what matches inside the parentheses. That's the x squared plus y squared. And then the second set, which is what's in front, the greatest common factors. So that's 3x plus 2y. And then that's my final answer here. So that initial greatest common factor that I had to factor out at the very beginning just kind of follows the steps all the way down until it's all the way in the front. If you forget to factor out the greatest common factor, when you get to the bottom, it won't be factored completely, and you will have to factor one of your sets of parentheses. On the assignment this week, I usually see a lot of people forget to take the GCF out. And so then their final answer is not correct because you haven't factored completely. So always check that first step to see if there's any factor in common, anything you can factor out before you go through the whole process. Are there any questions on this second example? Yeah, so Stacy, now you should double check if you factored your greatest common factor out, because I know that's a mistake I've seen over and over. Okay, now before I go into the AC method, I'm going to briefly go over the trial and error method just to show you why I don't like to use it and why I generally use the AC method. And that's there are some times where I'll do trial and error just because the numbers are so small. Like for this first example, if I was doing this on my own, I would probably do trial and error in that example. The second one might do trial error, might do the AC method. The bigger the numbers are, or the more choices I have, the more likely I am to use the AC method. So factoring by trial and error is very similar to when we were factoring without a coefficient in front, when it was just like x squared without that number in front. You're still trying to get two sets of parentheses, and you're trying to get numbers that multiply them. But now you have more combinations you have to consider. So for example, we have a 2w squared. So instead of w times w, I have to consider what also multiplies to 2. Now 2 is prime, so there's only one possibility, 2 and 1. So that means one of these has to be 2w, and then the other one has to be 1w. Because that's the only way to get those to multiply to 2w. Now, my last number, the constant, that's negative, and I'm adding to a positive, so I need opposite signs. But here's the problem. I don't know which of these is positive and which is negative. Is it the 2w that has a positive or the 2w that has the negative? When they were both w's, it didn't matter. But now that they're not the same, it matters. And so now we have to consider where the signs go in addition to what the numbers are. So it's called trial and error because you're basically guessing and checking and trying to get the right combination. So I need my last two numbers to multiply to a -3. So the only way that multiplies to 3 is 1 and 3. 1 times 3 there. Now I have to make sure I have the right signs by basically doing FOIL to check to see if I get the right combination. So we're multiplying the insides and the outsides. So the inside here, I have to make these positive and negative. So I'm just going to randomly pick here. If I multiply the inside, that's 1w. And then the outside's 2w times -3. That's -6w. That's 1w minus 6w. When you combine those, you get -5w. That is not what we want. We want a positive 5w. So that means our combination is wrong. Now, what's nice is if you do this and you get the correct number, but the sign is wrong, that just means you have your plus and minus in the wrong spots. So if I switch those, then I have a -1w, a +6w, and that gives me a +5w. And so that is correct, and so that's factored. So this one didn't take too long, and I just got lucky by putting 1 and 3 first versus if I had done 3 and 1 first. But this one is not too hard to do because there's only one possible way to multiply to 2. There's only one possible way to multiply to 3. So there's not a lot of choices, and you can do the guessing and checking to figure it out, the trial and error basically. The second one that I have here is a little harder. So I still need to have my parentheses. Now here's one of the problems. 6, there are multiple ways to multiply to 6. I can have 1 times 6 or 2 times 3. For 12, I could have 1 times 12, 2 times 6, and 3 times 4. So the first example, there was only one choice. Now I have lots of choices for numbers. So I don't even know what's going in front of my z's. So I have to leave little placeholders here. So I'm going to just highlight that I need to have numbers in front of these. I just don't know what the numbers are. And then I have to have numbers in the back, and then to also figure out what my signs are. I'm multiplying a negative, adding a positive. So again, I'm going to have a plus and a minus, but I don't know which one is which. So now we have to really make some guesses. So let's just say I first start with, oops, I'm in the highlighter. That is not what I wanted. I want to go to the pen. Okay, so let's just say I use 1 and 6 for my z's. So now I have to multiply the insides and the outsides here. And then let's just guess 1 and 12. And now I have to pick signs. So let's say I just do plus and minus. So when I do this, 1 times 6z, that is a positive 6z. 1 times -12, that's -12z. And 6 minus 12 is -6z. So that is not the right number. If it's not the right number, changing the signs is not going to do anything. So next, I need to check, well, what if I change the number placements? And I do 12 and 1. So 12 times 6 is 72. And I can look at this already and say, okay, these are getting way too big, because then I have 1 times 1, which is 1, and that's getting even worse. 72 minus 1. Well, now I have 71z, which is farther away than I wanted, because my goal is a 1, because that's what I have in the middle. I have plus z. So now that I've tried 12 and 1 in both of those places, I need to try 2 and 6. So let's just try 2 and 6. And sometimes you get lucky and it factors immediately, sometimes you don't. So inside, 2 times 6 is 12z. out 1 times negative 6 minus 6z, 12 minus 6, I'm at 6z. That is not the right number. So now we try to rearrange these. We have 6 and 2. So inside 6 times 6 is 36z. 1 times negative 2 minus 2z. 36 minus 2 is 34. So that's even farther away. So now I've ruled out 2 and 3. Now I need to 3 and 4, the other possibility. And if I was doing this on paper, I may not even bother erasing it. I might just keep writing it because otherwise you're going to wear out your paper. Okay, so inside 3 times 6 is 18z. 1 times negative 4, that's minus 4z. So 18 minus 4, that is 14z. That's not the number we want. So we erase it. And then we change the order. 4 times 6z is 24z. 1 times minus 3, that's minus 3z. 24 minus 3, that's 21z. Okay, now we've tried every single possibility that goes with 12, and none of these have worked. What that means is that our choices are not 1 and 6. So all I have ruled out is 1 and 6 in the front. So now I know it's a 2 and a 3, but I don't know which combination it is. So now I put in 2 and 3, so I know that for sure because those are the only choices left. And now I start over, 1 and 12. You can see how this can get very tedious because there's a lot of combinations. There's 2 times 3, but then you gotta reverse the order. So there's 12 different possibilities here. So 1 times 3 is 3z. 2 times negative 12 is negative 24. 3 minus 24, that's going to give me a negative 21, so that's not correct. And my goal here is to get 1, so I change the order. 12 and 1. 12 times 3 is 36. Outside 2z times negative 1 is negative 2z. And 36 minus 2, that's not going to be it. All right. So now for sure I have ruled out 1 and 12. Now I need to try 2 and 6. 2 to 3, that's 6z. 2 times negative 6, negative 12z. 6 minus 12, that gets a negative 6. That's not what we want. We erase. We flip. 6 times 3 is 18z. 2 times negative 2, that's negative 4z. 18 minus 4z, that doesn't work. So now we have ruled out 2 and 6. So now we know it has to be 3 and 4. If 3 and 4 doesn't work, then this is prime. Then it can't be factored. So now 3 and 4. 3 times 3, so that's 9z. 2 times negative 4, negative 8z. 9 minus 8 is 1z. I have finally found the correct combination. So the correct answer is 2z plus 3 times 3z minus 4. That's the trial and error method. And that constant having to check and make sure you've checked all the possibilities, that is why I don't like to use the trial and error method if there is lots of choices. It wasn't so bad on the first problem. The second one, that takes a lot of work. So are there any questions on the trial and error method? Okay, so now the AC method. So the AC method, which I call grouping, that allows us to minimize the guessing. We had to do a lot of guessing on that last problem we just did. With the AC method, you still have to do a little bit of guessing, but it's more the same type of guessing you do when there's no number in front. It's just like an x squared. It's not the same amount of guessing that we just had to do. There are some where you do have to do quite a few, but it's not as bad. And so you can use this method even if it's an x squared and there's not a number in front, but it's best used if there's a number in front of you, there's a coefficient from your x squared. So first step for everything is always to factor out the greatest common factor. So now this is called the AC method because you are multiplying the first and last terms. So you're multiplying just the coefficients of the first and last terms, A and C together. And now, so when we didn't have a number there, we're just looking for two numbers that multiply to C and add to B. With a number there, you're looking for two numbers that multiply to A times C and add to B. Once you do that, you are rewriting your middle term so that it's those two values added together. So you're basically you're splitting up your middle term so that it's, say, maybe px plus qx, if those are the two numbers that you found. So you're creating four terms. And you're creating these four terms in a way that now you can factor by grouping, and it will always work out, presuming that you use the correct numbers. If you split it up p and q incorrectly, then you will end up to a point on the grouping where it doesn't work. And that tells you that you messed up somewhere. So if you do this right, it will always work out. So I'm going to show you how it works with a normal trinomial that we would normally just factor by just saying two numbers that multiply to 40 and add to 6, essentially. So if we're going to use the AC method here, A is equal to 1. Let me just change that color. So A is equal to 1 because there's no coefficient in front of the y squared. And C is equal to negative 40. So A times C is negative 40. Now we're looking for two numbers that multiply to negative 40 and add to negative 6. So this is the same process that you did before. You look for numbers that add to 40, and you need to get them to negative 6 here. So because they're multiplying to a negative, one of the numbers is positive, one is negative. And so you can start making guesses, 8 times 5. But let's see, if the middle number is negative, then that would be the two numbers, the 8. The 8 has to be negative. So negative 8 plus 5, that is negative 3. So that's not it. But we do have, say, a negative 10 and a 4. Negative 10 plus 4 gives us negative 6. So normally those would be the numbers that you would use. You would say it's y minus 10, y plus 4. I'm going to show you how to get to the same answer using grouping. So how this works is now we're rewriting this. So we have y squared minus 10y plus 4y minus 40. So doing the factoring this way is slower than using trial and error in this case, but I'm just showing you that it works. So we basically took that minus 6y and split it up so that we have minus 10y plus 4y. Now we need to pair things together. Oops, I'm in the highlighter. I keep doing that. So I'm going to pair my y squared minus 10y and my 4y minus 40. And I need to look for the greatest common factor in each pairing. So in the first pairing, I can factor out a y. In the second pairing, I can factor out a 4. So when I factor that out, I'm going to write each step here. I'm dividing each, that's supposed to be a y, each term by the greatest common factor. And so I have my y in front, and then I got y minus 10, then plus 4, and then that gives me y minus 10. And so now my parentheses match, so that's my first factor, that's y minus 10. And then the next is the greatest common factors from each part, the y plus 4. So you get the same answer factoring by grouping using the AC method that you would have if you just did the guessing and checking that we do for something of this form, where there's no number in front. It's a lot easier and a lot quicker to just do the guessing and checking in this case because there's no number in front of the y squared. Are there any questions on this slide? Okay. Example 4. Now this is one we have a number in front, and this is really where the AC method shines. So the number in front of the y squared, that is a. So a is equal to 2, and then c is equal to 6, the last number there. So a times c is 2 times 6, that is 12. And so now I'm looking for combinations that multiply to 12 and add to 7. So that could be 3 times 4. Since everything's positive, all the numbers are going to be positive. So 3 times 4 is 12. 3 plus 4 is 7. So I'm going to rewrite this as 2y squared plus 3y plus 4y plus 6. Now the order that you write those middle terms, it doesn't matter. It will factor either way. So if I had done the 4y first and then the 3y second, that would be fine. It would still work. And now I'm pairing these up. So I'm grouping the first two and the last two together. And then I need to find the greatest common factors. So in the first pairing, I can factor out a y. In the second pairing, I can factor out a 2. So when I divide, oops, I wrote a 2 there. I'm dividing a y out of the first set. And then I'm dividing a 2 out of the second set. And I usually do this step in my head, but I just want to show all the steps here. So inside my first set of parentheses, I get 2y plus 3. Since the y's cancel in the last term, and then a 2 minus 1 gives me an exponent of 1 in the first term. Then plus 2, then 4 divided by 2, I get 2y plus 3. And so the first set of parentheses is what's matching in the parentheses, the 2y plus 3. The second set is what's in front, y plus 2. And that actually wasn't too bad when you compare that to when we had a guess and check. Because it was fairly easy to figure out the two numbers that get to 12, and then from there, the hardest part is probably determining the greatest common factor. And then you just kind of follow your rules from there. You don't have to, once you have the rules in your head and they become automatic, there's really not a lot of thinking involved anymore. And notice that the combination, it's 2y plus 3y plus 2. That's different from the 3 and 4 that we found. So 3 and 4 gave us the 7, but that was not what we needed to use. We can't just stick those in the factoring that way. So are there any questions on this example?
I don't have a question on this example, but if there's time, there was a skill practice one in the book that had the A and the C, and there were two pairs of factors that equaled the middle number. So it's kind of sort of a guess and check, trying to pick between those two that would work right.
There should be only one possible pair that would work to get to the middle. So if there isn't, then something went wrong elsewhere.
That's very possible.
So it could be a sign error somewhere, and that could be a potential issue. So I would just double check because there will be only one possible pairing that will work with the correct signs. So it's entirely possible to get to that middle number, but with different sign so you have to pay attention. Like here, I knew that because I was multiplying a positive and adding a positive, both of them had to be positive. Um, so that makes there's only one possibility. This one's another one where they're still positive. Um, Let me just skip to this one because this one has a negative and a positive. So this one we have to worry a little bit more about our variables. So here we have 20a squared plus 3ab minus 9b squared. So because of the 20 and having lots of choices of 20, I would not be doing this by guessing and checking or trial and error. I would not do that. So A here is 20, C is negative 9, so A times C is negative 180. So we are going to have a lot of choices. There are a lot of numbers that multiply to 180. But we do have to consider that negative because one of them is negative, one is positive. And then they're subtracting them. We're looking at the subtraction to get us to a plus 3. So I'm going to just sort of make a chart here. And I usually start with the numbers that they give us, the 20 and the A and the C, because those are multiplied to negative 180. So 20 minus 9 gives me 11. Now I know that 20 has to be, because the middle number is positive, the biggest number has to be positive. So the 20 is bigger than 9, so that has to be the positive there. Now 20 minus 9 is it's 11. It's not close to 3, but it's not too far off. It's closer than if I had started with 180 times 1. So it just gives me a starting point. So I'm going to just start taking my calculator and just saying, okay, does 19 go into 180? No. 18 goes into 180. So that could be 18 times 10. So I have to make sure, because I'm trying to get a positive, the bigger number is positive. 18 minus 10 is 8. So I'm getting closer. So I'm going to continue walking down with my 20s. And this way I didn't start by 1 times 80 and then have like tons of possibilities here. I'm just sort of starting in the middle and then determining where I need to go from there. So you can try 180 divided by 17. So there's a little guessing and checking here. 180 divided by 16, and you just keep going until you get a whole number. So 180 divided by 15 gets me a whole number. So that's 15 and 12. If I do 15 minus 12, that gets me my positive 3. So now I'm going to rewrite this as 20a squared plus 15. Now, because our middle term is AB, I'm going to use AB here. So that's going to be 15AB. Then always put a plus sign here. So I have a minus 12. Don't put minus 12 because that's going to mess things up when you start having the grouping. Always put a plus sign there. And then we have minus 12AB and then minus 9B squared. So by putting that plus sign, that allows you to have that grouping. You have to have a plus in between. And the negative is going to go in the second grouping. So now I need to find the greatest common factor. So out of 20 and 15, I can divide out a 5. And then I have an a squared and a, so I can factor out an a. The second grouping, whenever that first term is negative, you're always going to factor out a negative. So I'm going to have a negative here. And then I can divide a 3 out of 12 and 9. And I can take out a b. So my GCF is negative 3b. So now I'm going to write my division here. And feel free to interrupt if there are questions. So I have my minus 3b, and I wrote minus plus minus 3b. If you wanted to, in this case, you could just say minus 3b. That's fine. And then negative 12ab over negative 3b minus 9b squared. I am running out of room here. I should have switched colors. So I'm sort of leaning into my table there. So I have a 5a. 20 divided by 5 is 4. A squared over a is a. 15 divided by 5 is 3. The a's cancel. We have a b. Then minus 3b. Now I have a negative 12 divided by negative 3, so that's going to positive. The b's cancel, so I get a 4a. And then I have a negative 9 divided by negative 3, so that's a positive 3. And then b squared over b gives me b. So I had to take out the negative. If I did not, these would not match. The signs on the right one, the second set of parentheses, would be opposite. So that's why you have to take out the negative, because otherwise these will not match. So once they match, then we have 4a plus 3b and 5a minus 3b. Are there any questions? Let's see, I have lots of examples. Do you guys need more examples? Do you want me to go back and do example 5 or maybe example 7, or do you think you have this?
Do you think you have one? Do you have one that has like a beginning where the first coefficient is a negative?
I can make one.
I'm just asking because I have a positive negative issue, so.
Let's just make this one. So I will rewrite this one. And we will just make that negative, that coefficient negative. And actually, in order to make this work properly for sure, I will just switch all of the signs there. So let's just make that a negative 14y squared minus 50y minus 24. So here, if that first thing is negative, we need to factor out a negative for your greatest common factor. You could do the AC method without it. It's just a lot easier if you do that. So I need to factor out a negative here, and then I also need to find out what number goes into 14, 50, and 24. Now 14, the only things that really go into it are 1, 2, 7, and 14. 7 doesn't divide into 50 or 24, and 14 does not divide in those numbers. So I know that 2 is the largest number I can divide out here. So my GCF here is going to be a negative 2, because I'm going to take out that negative. So I'm going to just divide all of these numbers by negative 2. I'm not going to show the step where I write the division, but I'm going to just do that division. So that means all of the signs change because I'm taking out a negative, and then I'm dividing all of the numbers by negative 2. So now with the AC method, I'm going to take the 7, so that's A, and then the 12, that is going to be C. So A times C would be 7 times 12, which is 84. And so now I'm looking for two numbers that multiply to 84, and because these are all positive, they need to also add, and they're going to add to 25. So I'm going to just start with 7 and 12. So 7 and 12, that gives me 19. And Stacy's already got it. 4 and 21. That is faster than I would have. I was going to start doing my calculator. So good job. 4 times 21, that gets you 84. And 4 plus 21 is 25. So now I'm going to rewrite this, and just for ease, I'm going to turn those first sets of parentheses to brackets so they don't get confusing. Then I have 7y squared plus 4y plus 21y plus 12. And then I'm going to put in my groupings. So now the GCF, I have 7y squared and 4y, so I can only take out a y because 7 and 4 don't have anything in common. And then out of 21 and 12, 3 is the only thing I can divide out of those. So these aren't going to get reduced too much. So I have the -2, and then a y, and if I remove a y, I'm going to get 7y plus 4. I'm just abbreviating my steps here. Then 3, and if I divide 3 out, I get 7y plus 4. So now, in parentheses, I have 7y plus 4 that matches. So that -2 is just out in front, and then I have 7y plus 4 and y plus 3. So if your first term, your highest term, is negative, even if there's not a number you can factor out, you can factor a negative and you'll just have a -1 in front. But you always want to take out a negative if that first term starts with negative, just so you don't have to mess around with it later. Does that help you out, Teresa?
Yeah, it makes a little bit more sense now.
Okay. Are there other situations, you guys? Do I have when the middle term is negative and the last is positive? Let's see. Middle term last negative, last positive. Okay, I'm going to have to find one because if I try to make these up, it's not going to work. So bear with me. I'm going to try to find some examples. I'm just going to try to Google. Okay, let's see. You wanted the middle term. Let me go back to that. Middle term negative, last one positive. Okay. No, that's the opposite. Okay, perfect. You found one for me, because if I try to make up something, it's not going to work, and it's just going to be a mess. Because I'll probably, the thing with factoring is that it's very likely we make up things that don't work. Oh, you guys both found some for me. Okay. Let's see, which one do I actually want to use? Which one looks like it might be? I'm going to do Teresa's just because of the oh no. Well, you know what, Stacy, you've got a y cubed in there. That one, I like that. So we're going to do that one. 9y cubed minus 30y squared plus 24y. Okay. So we have a greatest common factor we can factor out here. We're going to factor out a y for sure because there's y in all of these. So the greatest common factor we've got out of 9, 30, and 24. Let's see, 9 doesn't go into 30. So it would have to be a 3 that I can factor out. And then I can factor out a y. So I'm going to factor out a 3y. And this one I am going to write all the steps. So 3y, and then we get 3y squared minus 10y plus 8. So now A is 3, C is 8. And A times C is 3 times 8, which is 24. So we're looking for two numbers, And because we're multiplying a positive and adding to a negative, both numbers have to be negative. So if I just start with what I had, -3 and -8, that gives me -11. So that's not the right combination, but that's close. So yes, -6, -4, that gets us -10. So I'm going to have my 3y in front, and I'm going to turn this to brackets. Then I have my 3y squared minus 6y plus minus 4y plus 8. So I have to make sure I have that plus between because of those negatives. And then I'm going to group those together. So in the first pairing, I can factor out a 3y. In the second pairing, I can factor out a -4. I'm taking a negative because my first term there is negative. So I have 3y bracket 3y. Now, because I'm running out of room here, I'm going to just do the division in my head. That leaves me with a y minus 2. Then I'm going to have my -4 from the greatest common factor. And then I'm going to divide, and that also gives me a y minus 2, because an 8 divided by -4, that's a -2. So now I have 3y, then in parentheses, y minus 2, and then from the greatest common factors, 3y minus 4. So that's how it works if you have a middle that's negative and the last term is positive. So that means both numbers have to be negative.
That's the rule I was forgetting.
Okay, yeah. So that
Yeah.
could be where you came up with two possibles that worked.
It was a 2 and 12
Mm-hmm.
because I made the 12 negative and the 2 positive. So that's why
Yeah.
that both
Yes.
have to be negative.
Yeah. So so the signs are what forces you to have one option, because there's only one option where both of them are negative and add to -10. And if you'd used 2 and 12, you would have gotten to a point where you inside the parentheses they don't match.
Right.
And that what tells you, oh, I messed up. I used the
Yeah.
wrong pair of numbers.
Mm-hmm.
Are there other questions?
I have a question about one of the problems that was in the book, but I don't know. It's not like on the AC method, it's the perfect squares.
Okay.
Because it was like T2, what was it? It was T2 plus 144.
So if you wanted to do this method with that, you could say you have a 0 in between. And
Okay.
so you are looking for two numbers that multiply to 144 and add to 0. And the only way for them to add to 0 is they have to have opposite signs and be the same number. So that would give you, actually you can't have a plus here because
No, it's supposed to
that's
be minus.
prime.
Sorry. My bad.
Yeah, minus works. If it's a plus, it doesn't factor, and that's prime. Yeah, so you'd have to have a positive and a -12 to get to 0.
Okay, that makes more sense now.
And you can do that with the AC method then, even though you would have plus 12, minus 12, and you can go through the whole method.
Okay.
Anything else?
No.
All right, well, it sounds like you guys don't have any more questions, and I've had you for almost a full hour. So I thank you for joining me on a Monday night for this. I really appreciate that. If you have questions, like tomorrow, I have a lot of meetings tomorrow, but I will be checking my email. So you can email me. I can be quick to reply to emails during the day. So This should be everything that you need to get through the assignment. I know for sure on one of the assignment problems you have to factor out the greatest common factor, and you can use the AC method on both of them if you want. You can use whichever method works for you. So that's all I've got for you guys. Thank you so much for joining and interacting and asking questions.
Thank you as well.
You're welcome. Next session, I believe, is Thursday. I had my calendar up. Where did I put my calendar? I had it, and I think I accidentally closed it. Friday. So the next one is Friday on the quadratic formula. So next week when we're solving, we're not doing too much new stuff. I think it's like 2 sections. So 11 a.m. on Friday will be the next live. So hopefully I see you guys there if you can make it. All right, I'm going to pop off. You guys have a great evening.